Hi guys, and welcome back for today's STR8CHEM videos. I'm Fedrick from class F05. Today I would like to share with all of you the solution for question 6 diagnostic test 2. So the question is, a combustion device was used to determine the empirical formula of a compound containing only carbon, hydrogen and oxygen. If the data determined from a 0.6349 gram sample of the unknown is that 1.603 gram carbon dioxide and 0.2810 gram of water were produced, determine the empirical formula of the compound. Okay, so from the question, we had been given the mass of the sample, the mass of the carbon dioxide, and the mass of water. Okay, so first of all, before transfers all of the masses into our Mamora table, we need to find the mass of carbon, hydrogen, and oxygen. Okay, so here need to find the mass of carbon. Okay, so as we all know, the constant value for carbon is our carbon 12. Okay, that's our constant value for carbon, and then we need to divide it with the molar mass of carbon dioxide. So 12 plus with the molar mass of oxygen there. So the constant value for oxygen is 16. Okay, but because of 2 mole of oxygen here, we need to multiply 16 with 2. Okay, I hope you understand why so. Okay, and now we need to multiply it with the mass of the carbon dioxide given, which is 1.603, and we will get the answer 0.4372 gram. Okay, that is our mass of carbon. And now we need to find the mass of hydrogen from the mass of water. Okay, and now the constant value for hydrogen. Okay, where is hydrogen? Okay, 1. So 1. But because of 2 mole of hydrogen, we need to multiply it with 2, and then divide it with the molar mass of hydrogen, H2O, of water. So 152 plus 16, the molar mass of carbon, the molar mass of oxygen, sorry. So need to multiply it with and we will get okay, so this 0.2810 is the mass of water. Okay, had been given in the question. And last thing we need to do is find the mass of oxygen before transferring all of the masses into our Mamora table. Okay, how do we find the mass of oxygen? From the question, the mass of the sample is 0.6349. Okay, need to use a mass of sample, which is 0.6349 minus with the mass of carbon here and the mass of hydrogen. Okay, so how do we write it? With this. Okay, so this is the mass of the sample, mass of our carbon, mass of the hydrogen. Okay, from that we will find the mass of oxygen. The mass of oxygen is 0.1665 gram. Okay, that is the mass of oxygen. And now we need to transfer all of the masses, mass of carbon, hydrogen, and oxygen, into our Mamora table. Okay, let me draw a table first. Okay. Okay, that's enough. Now we have carbon, hydrogen, and oxygen. And we need to put Mamora, mass stands for mass, mole stands for mole, ratio, ARA stands for ratio, and then transfer of the masses into our Mamora table. So the mass of carbon is 0.4372. The mass of hydrogen 0.0312. The mass of oxygen 0.1665 gram. Okay, and now we need to find the mole each of these element. Okay, the mass, which is 0.4372 divided with the molar mass of carbon, which is 12, and we will get the answer for the mole of carbon is 0.0364. Okay, and we'll do the same thing for hydrogen here, over 1 because of the molar mass of hydrogen, and then multiply, not multiply, we'll get the same thing, 0.0312. Okay, and now for oxygen, still the same thing, 16 because of molar mass of oxygen, and then we will get 0.0104. Hope this is visible. And redo it. 0.0104. Okay, it's quite confusing. Okay, so how are we going to find the simplest ratio? First, we need to identify which mole is the smallest. Okay, need to identify which mole is the smallest. So of course the mole of oxygen is the smallest. value amongst these three. So what we're going to do is we need to divide the all mole with the smallest value here, which is 0.0104. That is our smallest value, right? And then we will get 3.5. Okay, so let add 3.5 there first. Okay, so now we're going to move with the second one over the same thing, 104, and we will get 3. Okay, now divide with itself, we get 1. Okay, because as we can see here, they are 3.5. 3.5 cannot be run off. So what are we going to do? We need to multiply it with something so that it can be whole number. Okay, so in this case, we need to multiply it with 2, and we will get 7. Because this part we had been multiplied with 2, all of this need to be multiplied with 2. So we'll get 6 and 2. Okay, so we're nearly there. And then the empirical formula is C7H6O2. Okay, that is our final answer. Okay, so I hope you guys understand this type of question. Okay, I hope you guys know how to solve this kind of question. Okay, so I guess that's all from me. Thank you for watching.